Hey everyone, welcome back. Today we are jumping into Math 20-1, Algebra and Number, Outcomes and 2 and 3. Radical expressions and radical equations. If this helps you, subscribe to the channel and like the video, because it tells me to make more lessons like this. By the end, radicals should feel less mysterious and a lot more manageable. A radical is an expression with a root symbol. The most common one is a square root. The square root of 25 is 5 because 5 squared is 25. The key idea is this. Radicals ask, what number, when powered, gives the radicand? For square roots, we are asking what number squared gives the value underneath the radical sign. Before simplifying radicals, memorize your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These numbers are your shortcut map. When you see a radical, look for the largest perfect square factor hiding inside it. Let's simplify square root of 72. The largest perfect square factor of 72 is 36. So we rewrite square root 72 as square root of 36 times 2. Square root 36 is 6, so the answer is 6 square root 2. The 2 stays inside because it has no perfect square factor left. Math 20-1 often asks you to move between entire radicals and mixed radicals. 6 square root 2 is a mixed radical because part of it is outside the root. To turn it into an entire radical, square the outside number and move it inside. 6 square root 2 becomes square root of 36 times 2, which is square root 72. Adding and subtracting radicals works like combining like terms. You can only combine radicals when the radical part is exactly the same. For example, 3 square root 5 plus 7 square root 5 equals 10 square root 5. But 3 square root 5 plus 2 square root 3 cannot be combined because the radical parts are different. Here is a more realistic example. Simplify 2 square root 18 plus 3 square root 8. First simplify each radical. Square root 18 is 3 square root 2, so 2 square root 18 becomes 6 square root 2. Square root 8 is 2 square root 2, so 3 square root 8 becomes 6 square root 2. Together, the answer is 12 square root 2. Multiplying radicals is friendly. Multiply the numbers outside, multiply the numbers inside, and then simplify. For example, 3 square root 5 times 2 square root 10. 3 times 2 is 6, and square root 5 times square root 10 is square root 50. Square root 50 simplifies to 5 square root 2, so the final answer is 30 square root 2. Dividing radicals sometimes leaves a radical in the denominator. In Math 20-1, we usually rationalize the denominator. For example, 5 divided by square root 3. Multiply the top and bottom by square root 3. The denominator becomes 3, so the answer is 5 square root 3 over 3. Same value, cleaner form. If the denominator has 2 terms, use a conjugate. The conjugate of 2 plus square root 3 is 2 minus square root 3. Multiply top and bottom by that conjugate. The denominator becomes 4 minus 3, which is 1. That is the magic of conjugates. They remove the radical from the denominator. Now for radical equations. The big strategy is isolate the radical, then square both sides. Solve square root of x plus 5 equals 7. Square both sides to get x plus 5 equals 49. Subtract 5 and x equals 44. Always check. Square root of 44 plus 5 is square root 49, which is 7. Here is the danger zone, extraneous roots. Solve square root of x plus 6 equals x. Square both sides to get x plus 6 equals x squared. Rearranged, that is x squared minus x minus 6 equals 0. Factor to get x minus 3 times x plus 2 equals 0. So x equals 3 or negative 2. but checking matters. -2 does not work in the original equation, so it is extraneous. The only solution is x equals 3. Quick recap. Simplify radicals by finding perfect square factors. Combine radicals only when the radical parts match. Rationalize denominators when needed and use conjugates for two-term denominators. For radical equations, isolate, square, solve, and always check for extraneous roots. If this lesson made radicals less painful, like the video and subscribe for the next Math 20-1 lesson.